Okay, so this is the second video in this chapter that we're talking about trigonometric functions. In this video, we're focusing on the child sine function and the child cosine function. To graph the child function, we're given y equals a times the sine of the quantity b times quantity x minus h plus k. Now, you see I have square brackets around here. You can do that in your calculator, or you can do double parentheses. It doesn't matter, but you have to have all of this inside these double parentheses to make it work. Same thing with the cosine function. Okay, so just be sure you're using the appropriate one. And like we've done in the past, to graph our transformed child function, we're going to start by graphing our parent function, then shift the graph k units vertically, h units horizontally. We've done that in the past. Then, if a is negative, we reflect the graph into line y equals k. I call that the midline. This has got to be done after any vertical and horizontal shifts have been performed. So what we're going to do in the next couple of examples is go through. We have the graphs here. We're going to talk about what a, b, h, and k are, talk about what they mean, and then double check that we have everything we're supposed to on the graph that's given. Okay, so in example 34, I have negative 2 plus 3 sine of 4x. Let's compare it to our child function. Negative 2 plus 3 sine, oops, I'm just rewriting the problem. The child function is given by a sine of b times x minus h, double parenthesis plus k. You've got to have this double parenthesis here because all of this is tied up with the sign. If you don't, it's not going to come out right. Based on the pattern here, I see that the number in front of the sign is 3, so that's a is 3. Also, I see the number by itself is k, so that's going to be negative 2. And based on the pattern here, the number in front of the x is 4, so that's got to be my b. Alright, now, let's talk about what each of these mean. Since a is positive, that means there's no reflection in our graph. B is 4, that tells me that my period for this graph is going to be 2 pi over the absolute value of 4, which is just going to be pi halves. Now, if you need to do this in your calculator, that's totally fine. And k equals negative 2 means there's a vertical shift. And we also know that the midline for this graph is at y equals negative 2. And finally, there's nothing for h, so h is 0. So no horizontal shift. Alright, let's talk about first, start off with the midline. Y equals negative 2. Here it is. We found that because there's a vertical shift. Originally, when we talked about the parent function, the midline was always the x-axis. It shifted down 2 units. We also know that since a is positive, there's no reflection, and also the amplitude of this graph is given by the absolute value of a. So the amplitude is 3. Again, that's the distance from the midline to the top of the wave, and the distance from the midline to the bottom of the wave. So everything's working out great so far. Also, since it's the sine function, we know that the parent sine function typically started at 0, 0. But since we've shifted down 2 units, the starting point of one cycle is starting at 0, negative 2. It starts on the midline, which is exactly what's happening. And we also know that for the parent sine function, it always goes from the midline to its maximum point, back to the midline to its minimum point, and it finishes one cycle at the midline. Okay, so since it's going in that order, middle, max, middle, min, middle, it's going in that order. There's no reflection, and that's exactly what we saw because a is positive. And finally, the period is pi halves. So we can go from here all the way up to pi halves. So we have a little bit more than one cycle of the wave shown, but everything's checking out exactly the way it's supposed to. So that's it for example 34. Example 35, we have a cosine function. So let's first off, like we did before, compare it to the child cosine function. We're going to list out what we know is supposed to be true and then compare it to what's actually drawn and see if we got everything we're supposed to. So y equals a times the cosine of 2/3 x minus pi fourths plus, and I'm doing it again. I'm just rewriting the original problem. I don't know why I keep doing that. Got to get it together. So I have a cosine of b times x minus h plus k. I guess I'm trying to get ahead of myself or something. I don't know. Anyway, sorry about that. Based on the pattern, the number in front of the cosine is 2, so I have a equals is 2. It's positive, so no reflection. And the number outside the parentheses, but on the inside of the cosine is 2/3, so that's got to be my b, which tells me that my period is 2 pi over 2/3. Again, that's a fraction, so it goes in parentheses. Now, I can do this in my head, but if you need help, use your calculator. Just do not hit the pi key. The pi just comes along for the ride, so it's going to come out to be 3 pi. Okay, and based on the pattern, h, it's going to be positive pi force, so there's a horizontal shift. And since it's positive, it's going to shift right. And then there's no vertical shift. Also, since there's no vertical shift, I know the midline of my wave is at y equals 0. Okay, let's start off with the midline. It's supposed to be y equals 0. And it is. The midline cuts the wave exactly in half. We know that since it's the cosine function, we typically start at 0, comma, whatever a is, our maximum, but we shifted that to the right, pi force units. So that's going on. So here's pi force, because here's pi, and it's cut up into 4 pieces. So we have pi force right here. So we've done our shift. So the entire wave is shifted over just a little bit. We know that since a is 2, there's no reflection. And I can see that in the graph because I know cosine is supposed to start at its maximum and finish in its maximum. That's what the parent function does. And I know that the period is 3 pi. So I'm going to start at my maximum and go all the way out. And one cycle of the wave is shown. Everything's working out the way it's supposed to. That's it for example 35. Example 36, we got -3 times the sine of x. Looks pretty innocent, but I'm going to still start off with my child function, list out what's supposed to be there, and then compare it to what's actually drawn. So y equals a times the sine of b x minus h, double parentheses, plus k. The number in front of sine is a equals -3. Since it's negative, that means there's yes a reflection. B is 1, which is going to just mean the period stays the same at 2 pi. H is 0, so no horizontal shift. And K equals 0 means no vertical shift. Also, we know the midline of the wave is at y equals 0 now, okay? Because the midline follows the vertical shift. Let's start off with the midline. The midline is supposed to be at y equals 0, which is just a fancy name for the x-axis. That looks good. We also know that the amplitude is the absolute value of a, so that's supposed to be +3. And again, the amplitude is the distance from the midline to the highest point in the wave. 1, 2, 3, that checks out. And the amplitude is also the distance from the midline to the bottom, the lowest point of the wave. 1, 2, 3. So that checks out. Now, there's no horizontal shift, no vertical shift, so we don't need to worry about that. We know that the parent sine function always starts at 0, 0, and that's what it's doing. But remember, the pattern was middle, max, middle, min, max. That was for the parent sine. This one's doing the opposite. Middle, min, middle, max, middle. So there is a reflection, and we know the period is just 2 pi. So we see one cycle of the wave. Again, the first hill that you're going to see in the parent sine is the maximum, but since it's a reflection, the first hill that we see in this graph is the minimum. Example 37, we have -1/2 cosine of 2x plus 3 pi plus 1. Start off with what? Our child function. -1/2 cosine of 2x. A times the cosine of b x minus h plus k. Alright, so based on the number in front of the cosine, I know that a is -1/2. I know that k, the number outside by itself, is 1, and that tells me that the midline, there is a vertical shift, and I also know that the midline for this wave has gone up to y equals 1. Since a is negative, I know there is, yes, a reflection. Now, before I can figure out what B and H are, I've got to look on the inside. I have to do a little bit of scratch work. This piece has to match up with this piece. It doesn't quite match because I'm supposed to have parentheses on the inside. So to fix this, what I'm going to do, now 2x plus 3 pi. Well, I don't see a GCF that I can pull out, but I know I want a nice number on the outside of my parentheses, so I'm just going to pull out a 2. And I want to think, all right, well, what times 2 will give me 2x? Well, that's going to be x plus what times 2 will give me 3 pi? Well, that's going to be 3 pi over 2. The reason is if I multiply 2 times 3 pi over 2, that's just 3 pi. So I can rewrite this exactly what it looked like this. So now, based on this, that means that b equals 2 and h equals negative 3 pi over 2. Again, it's always x minus h. I'm just following the pattern here. Well, since b equals 2, I know that the period is 2 pi over 2, or just pi. I didn't show the scratch work there because I was running out of room. But remember, it's 2 pi over the absolute value of b. So do that scratch work if you need to. And here I have a horizontal shift of negative 3 pi over 2. So we typically start for cosine at the y-axis, but now my starting point has shifted over negative 3 pi over 2. So this is actually my starting point. Again, we typically start at the y-axis, but we shifted all the way out here. So that's the starting point of my wave. The midline is supposed to be at y equals 1. That's exactly what's happening. And we know the amplitude is 1/3. It's from the midline to the highest point, so a equals, or sorry, 1/2. That makes sense. 1/2 goes from the midline to the lowest point. And we can kind of see that makes sense because the midline is 1, here's 2, halfway between, amplitude 1/2. So everything's checking out so far. And finally, the period is pi. Now, we start at negative 3 pi over 2, so that means one full cycle is going to go up to pi over 2. We also know that there's a reflection. We typically start at the maximum value for cosine, but this time we're starting at the minimum value, so that indicates a reflection. We started at the minimum and we finished at the minimum. So here is our full cycle. Okay, so this example, everything checks out the way it's supposed to based on what our child function gave us. We just had to do a little bit of extra scratch work. Okay, in example 38, we're riding a Ferris wheel and your height h and feet above the ground at any time t in seconds can be modeled by this equation. Looks complicated, don't worry. We're going to graph your height above the ground as a function of time. So let's go ahead and do that. Instead of h, that's going to be my y, t is going to be my x. Height is my output, t is my input. So we go to y equals, just put this in y1, so all of this is y1, 25 sine of, that's a fraction, so it goes in parentheses, pi over 15, close parentheses, parentheses again, x minus 7.5, close parentheses, and then finally my bracket has to be there, so close it again. Then plus 30. Now, we have lots of extra parentheses here. If you do not put those parentheses in, it's going to come out wrong. I want to graph this. I'm going to do zoom 7. Nothing really shows up, so I'm going to do zoom fit. Okay. And I want to zoom 7 again. All right, so now what I want to do is go to my window. I know my maximum value has to be 25, but there's also a vertical shift of 30. So I'm going to say my x min, I just want to go from 0 to 2 pi. I just want to look at one cycle only. And my y values, I'm just going to say the y min is 0. The maximum is going to be, say, 60, just so I got plenty of room in graph. And something is not. Oh, I'm not in the, yeah, mode, graph. Oh, it's so the Ferris wheel turns for 135 seconds before it lets the first passenger off. So my window, my x values are wrong. So I need to go from 0 to 135. Sorry about that. And there I see my wave. So the Ferris wheel, if I go to my graph, goes up and down, up and down. Here's the highest point that you're going to be on the wheel, the lowest point you're going to be on the wheel. We want to find the maximum and minimum heights above the ground. So I'm going to do second count, option 3 for minimum. I'm going to just say left bound, I need to be on the left side of the valley. Right bound, I need to be on the right side of the valley. And put it in the middle. My minimum value is y equals 5. Since we're talking about a height, how high above the ground, we're looking at y values. So the minimum, y equals 5 feet. And the maximum, second count, option 4 for maximum. Left bound, you just need to be on the left side of the mountain. Right bound, you need to be on the right side of the mountain. And guess you need to be on the top of the mountain. And the max, again, you're looking at y values. Max is y equals 55 feet. Now again, when you're talking about max and min values, you're talking about y values. You're not looking at the x values that the calculator gives you. That just are moments in time. We're looking at the height, y values. That finishes off for example 38 and for this chapter. As always, if you've got any questions, please let me know.